Hello. In this video, we are going to learn what the geometry merger does. The merger works in three main phases, depending on selected options. Phase 1 is to merge near equal 3D data points into single common points. Phase 2 merges adjoining faces into meshes. Phase 3 fits meshes to a variety of surface and solid forms. The merger results in smaller, more manageable models which render faster and with higher quality. Before we go over the features, let's watch the merger in action. The model you see here is representative of models exported from other engineering systems. In this case, as a DWG composed of about 25,000 3D face entities. Let's look around for a few seconds. Okay, you zoom in and selection preview shows that it really is a bunch of faces. Plenty of detail underneath. Okay, let's see what happens when we run the merger command. We will now open the Offset Tools ribbon section, and there's the geometry merger icon. We will discuss the settings for the geometry merger later. Right now, let's just run the command. For 25,000 faces, it should take about that long. Let's look at everything again. And now you look at the properties of everything in the drawing, and instead of 25,000 faces, we now have lots of meshes, some surfaces, and solids. Let's look at them in a bit more close up. And here you see, meshes. We still have meshes. But we have a sweep here. We have a revolution there. Lots of revolutions. Lots of big fancy meshes. And these are real surfaces that you can tweak in various forms. Scale it up, scale it down. Anyway, hopefully more useful than faces, don't you think? Alternatively, you could have opted to create meshes only, in which case you would have just gotten meshes with no surfaces and solids. Also, adjacent faces in the meshes whose normal vectors point in opposite directions have their vertices and normals reversed, such that each mesh has a consistent front side for material mapping and realistic rendering. One more thing about merging to meshes and meshes only is that they have the most compact footprint, on file and in memory as well. Note that the sub-D mesh merged drawing is less than half the size of the all faces original drawing. Then, promoting meshes to surfaces and solids increases the footprint back up, although it will still display much faster and better than the original faces. Rendering forms with textured materials works much better with meshes and surfaces than with faces. The resulting mesh in this case will render about twice as fast as the original faces in AutoCAD 2012 and 2013. However, our observations in AutoCAD 2014 indicate that something drastic has happened to the speed of rendering faces in realistic visual style, while meshes continue to render at about the same speed. Let's look at the geometry analysis capabilities of the merger in greater detail for a moment. To do this, we have hidden the meshes for a moment, and we have inserted the parameter profile block that was created by the merger. As we zoom in to the created surfaces and solids, we see that they all now have parametric entities aligned with them. For example, this revolution has its revolution profile and its revolution axis depicted. This sweep here, you can see its sweep path, and at one of the ends is in fact the sweep profile. Another revolution here, again you see its axes and you see the revolution profiles. For lofts, you get all the ribs, essentially. The profile parameters all reside in a single block definition. It's easy to edit, analyze via program, also easy to purge when you're done. Now that we have seen the merger in action, let's revisit its features in more detail. The command first analyzes all the vertex points collected from the faces and meshes, and merges those which are within the configured point tolerance distance from each other into a single point, thus repairing data which AutoCAD would treat as unequal. It then merges faces with shared edges into meshes, which are inherently more efficient to display, store, and render, usually by a factor of almost 4x. Even existing meshes will have near equal points merged, which can make some near watertight meshes completely watertight. If desired, the merger will then analyze all meshes for potential conversion into surface and solid entities. Also optional, the merger can record all the parameter geometry as entities in a single block, which can then be analyzed, inserted, and reference edited as desired. For you programmers, there are embedded Xdata links between the resulting entities and their parameter entities. Finally, for this version, there is an optional log file. We will discuss its usefulness later. Well, that's all for now. We will learn more details about the merger command settings in another video. I hope that you gained a better understanding of what the geometry merger does. Goodbye.